One of the greatest accomplishments in the field of medical science was the organ transplant. The idea that you could remove an injured or diseased organ from one patient, take a healthy organ from another patient, living or dead, and then place that healthy organ into the first patient, with that healthy organ effectively taking the place of the old one, was mind-blowing. However, the need for this life-saving procedure has only increased. New breakthroughs in the medical field have us living longer, but as we age, our risk for organ failure only increases. And as the demand for organs increases, the amount of organs available has stagnated. And even if a patient does receive one of these organs, the fear of the body rejecting the organ is still present. Luckily, this need has spawned a field of medical science known as regenerative medicine, which includes the field of bioprinting. This field actually started back in 1938, when Alexis Carrel and Charles A. Lindbergh wrote the book titled The Culture of Organs, which outlined many of the procedures now used in bioprinting. In 1954, the first predecessor to bioprinting, the organ transplant, first happened in Boston, Massachusetts, at Harvard, where they transplanted a human kidney. These procedures were used by Charles Hull in 1984, when he invented the first form of bioprinting called stereolithography. This form of bioprinting involves creating a scaffolding in the form of the desired organ out of organic materials and then coating that scaffolding in the patient's cells. By coating it with the patient's own cells, the doctors reduced the risk of the patient's body rejecting the new organ. All of this was done by hand and took weeks to complete. In 1992, the first 3D bioprinting machine, or SLA, was created by a company called 3D Systems. This machine could apply the patient's layer of cells over the scaffolding instead of the scientists doing it by hand. In 1999, the first lab-grown organ, a bladder, is successfully implanted in a human being. In 2002, scientists engineered a miniature functional kidney that was able to filter blood and produce urine in an animal. In 2009, Organav, a bioprinting company, teamed up with Inventec to create the NovoGem MMX bioprinter. They were successful in using it to create the first bioprinted blood vessels. In 2011, Tevido, a U.S. company, successfully printed breast tissues with nipples and cellular wound covers. In 2014, 4 students from Leiden University in the Netherlands came up with the concept of 3D printing skin replacements for severe burn victims. However, the actual development of this project won't begin until 2019 at the earliest. In 2017, a 3D printed ovary enabled a mouse to give birth to healthy pups at the Wake Forest Institute for Regenerative Medicine. While the field of regenerative medicine has come a long way, it still has a long way to go. If you think about it for a moment, organs are incredibly complex organisms that are constantly doing things, such as sending and receiving chemical signals, removing dead cells, making new cells, and so forth. So trying to 3D print an organ is similar to trying to create an entire factory all at once. Also, while you are printing the organ, the clock is ticking. If tissue doesn't receive the nutrients it needs, it can die within hours. Some tissues can absorb nutrients by diffusion, but if the tissue is any thicker than a dime, that doesn't work. So, with solid organs, like livers, you can end up with a living exterior, but a dead core. And of course, the biggest problem is that these organs need to be perfect. If your heart stops running for 2 minutes, you die. Scientists can't even afford a 1% fail rate on this. Science may have a long way to go before it's bioprinting organs for the general public, but it remains a promising field of medicine that's not giving up anytime soon.